Alright guys, what's up? It's your boy, Mr. Ellis. Hopefully I've done a good job of kind of setting all this up already, so I'm not going to explain too much. We're just going to do some math. Follow along in whatever way I told you to. Okay, number one, super easy. We're just asked to find the slope of the line. Remember, slope is in the form of rise over run. So you're finding 2 points. These are already given to me, and you're just counting how far up am I going, how far over. Remember, we always want to go to the right. It just makes your life a whole lot easier. So in this case, I'm going up 1, 2, 3, 4. And I'm going over 1, 2, 3, 4. So that would be a 4 over 4, which simplifies to a positive 1. We know it's positive because it's going up anyways. So that one was going to be pretty easy. Nice one to get started with off the bat. Number two, we're just plugging in. Well, you're solving for b. You're just solving this equation. This is just getting the b by itself. If you needed to just plug numbers in, that's a possibility here. You see the little star. But we'll do it the real way, I guess. Over here, I've got a distributive property. So I'm going to distribute. This is a negative 2. Hopefully you saw that negative in there. So negative 2 times negative 4 is positive 8b. Negative 2 times negative 2 is a positive 4. I've got a 4 plus 8b on that side as well. Now, I kind of already know the answer, to be honest with you, but because you'll notice 4 plus 8b is on this side and 8b plus 4 is on this side, same thing. But in case you didn't notice that, that's fine, because the next step would be to get the b's on the same side. But when you do that, you'd be subtracting an 8b minus 8b, and then 8 minus 8 goes away, 8 minus 8 goes away. You're just left with 4 equals 4. Is that true? Why, yes. Yes, it is. So that would be all real numbers. If you ended up with like 4 equals 2 or 4 equals literally anything other than 4, something that's not true, then that would be like no real solutions, but that's not even an option here. So just one of those things, like after we distributed that negative 2, we ended up with the exact same thing on both sides. So this is the same as this, no matter what. Cool. Moving on. Number 3. This says write the standard form of the equation. So see how all of these are in standard form, x, y equals number. It's a lot easier for us to find slope-intercept. So there's technically a few ways we could do this, but the most common way is typically just to solve these for y to get them to be like y equals mx plus b. When you do that, it's a lot easier to see what this line should be. By the way, the target that we're going for here, we would have a y-intercept of negative 2. So this would be a negative 2 right here. And then the slope is rise over run, so just find kind of 2 points here. I'm going down 1 over 5, so minus 1 over 5, that's my slope. So this is like our target. So whichever one of these is going to change into this would kind of be like the answer. So again, there's a few different ways we could do it. I guess my preferred method here, if I would say it like that, I think is okay to say, would be to just solve these for y and see which one ends up here. So if I take the a part, I'm just going to start with a, why not? And I'm going to solve this for y, so I'm just going to rewrite it x plus 5y equals negative 10. Subtract x from both sides, so the x's go away. 5y equals negative x and a negative 10. See how I just put them next to each other because they're not like terms. So you can't combine them. And then I'm going to divide everything here by 5. So y equals negative 1 over 5x, and then this would be a minus 2. And what do you know? The first one I tried, it's the exact same thing as that line right there. So it would be A on that one. Great. Moving on. This one is an exponential graph. Notice it's exponential decay as it's going down as we move to the right. Exponential decay means that your multiplier is a fraction, like it's smaller than 1. I went ahead and marked this one out just because of reasons. All of these are little fractions, so it's all going to lead us to decay. The way I would actually figure this one out is by our transformations. This is like the good dog, bad dog thing. So the bad dog which is typically inside of parentheses. In this case, the bad dog is inside of the exponent. This would be shifting to the left by 1, to the right by 2, and to the left by 1. But that's not as great as an indicator as these guys. These are my vertical shifts up and down. Remember our asymptote that we talked a lot about? That's typically right at 0. But if I look at this graph, the most notable thing about it, in my perspective, is the fact that instead of that asymptote being down here at 0, it's up here at 1. So it like I know for sure that it got shifted up from 0 up to 1. So that means this whole thing has been moved up 1, and the only one that's going up by 1 would be this guy. So I would go with C for this one. Moving on. Other page. We're going to factor. Again, this would be a great place to do like rule of 2. So this is that thing that we've been practicing that could be really helpful for a lot of people. Notice we've got X's in the problem and X's in the answers. So if you want to just put a 2 in for this and then put a 2 in for those and see which ones are the same, that's a great way to do it. But if you're interested in actually, learning math and stuff, I can help you with that too. This is a trinomial. There are no GCFs here, so I'm just going to be doing a standard little double bubble problem. I'll put my parentheses in. That's kind of how it gets its name, or reason why I call it that, because you got these are like little bubbles. Put the x's in front. That's what makes the x squared. We're going to see what my factors of 32 are. So over here on the side, I'm just going to make a quick list. 1 and 32, 2 and 16. What we got? 4 and 8, I guess. And then the question is, which one of these combinations adds to be negative 12? Well, 4 plus 8 is 12, so if I make them both negative, minus 4 and minus 8, that'll get me where I want to go. Negative 4 times negative 8 is positive 32. Negative 4 plus negative 8 is negative 12. So I just try and see which one that matches up with. So notice I'm going here. That's going to be my answer. But they are in opposite orders. This one went negative 8 and then negative 4. I went negative 4 and negative 8. That's okay. This is commutative property of multiplication. Commutative property means you can flip the orders, and that's cool. So we'll go with B. Yay. If you did rule of 2, that should have helped you out as well. Over here it says solve the following systems of equations. So again, a rule of, or not really a rule of 2, but just a plugging in would be like, for most of you, I would imagine that would be the best way to do it. Take this negative 1, put it where the x is, take the negative 3, put it where the y is, figure out does that equal negative 16, and then do the same thing with 2x plus y equals negative 1. And if you get one that works for both, then you know that's the answer. So that's a really awesome trick for this one. But in light of not knowing that, I'm going to actually show you the way that we learned it a long time ago. I'm going to solve this by elimination. Solving by elimination requires me to get my x's, y's, equal signs, and constants on top of each other. They're kind of like lined up correctly. So I'm going to be thinking kind of vertically. I'm going to be looking at my y's. I'm going to be looking at my x's specifically. And the question becomes, like, how can I take these coefficients and make opposites? It'd be great if I had like an 8 and a negative 8. 8 and a negative 8. That'd be awesome. Because if they are opposites, they'll cancel out, or eliminate as the method is called. None of these are opposites, so I just create some. What I'm going to do, I have like a few different options at my disposal. I'm going to make this into an 8. So to make a 2 into a negative 8, in order to be that opposite, I'm going to multiply it by negative 4. Negative 4 times 2 is negative 8. So I'm just going to rewrite this underneath it, negative 8x. The only kind of catch here is that if you multiply one piece of an equation, you have to multiply the entire equation. So I'm going to be multiplying all of this by negative 4. That's why I put those parentheses. So negative 4 times 2x gave me the negative 8x. Negative 4 times y is negative 4y. And negative 4 times negative 1 is positive 4. So I'm just going to kind of scribble out this middle one that I changed just so it doesn't confuse me. And what you'll notice now is I've got opposite coefficients. That's the whole idea of elimination, is trying to create that. So now we can add up, we're just going to kind of vertically add each of our things that are the same. 8 plus negative 8 cancels. 8 plus negative 4, that gives me 4y equals, and this is negative 16 and a positive 4. So that's going to be a negative 12. Then I can just solve for y. Y is negative 3, so that helps me a little bit. My y value has to be a negative 3. I can get rid of c. But then in order to kind of finish this, you're going to take the y value you just found and plug it back into one of your problems. It doesn't matter. You could even technically use the one that we just erased, which would actually probably be the easiest one, now that I think about it. But that's all good. We're just going to plug this in for one of these, and then that'll help us finish. So if I plug it into this guy right here that I had just made, that would be negative 8x, and that's a minus 4 times the negative 3 instead of the y. See how y becomes the negative 3, and that equaled 4. So simplify this up a little bit. Negative 4 times negative 3 is positive 12. So negative 8x, I'm going to subtract that 12 over there, and that becomes a negative 8, so x equals 1. If x is 1 and y is negative 3, then haha, there's my answer, it's D. Again, super easy to just plug these in, which might be, even if you're really good at elimination. Hopefully that maybe rings a bell of how we solve these, but even if you're like pretty good at this, if you can remember just plugging these in to see which one works, that might be even easier. You know what I mean? So yeah, really good opportunity to use like the plug-in value tricks that we've been practicing. But there you go. Solving by substitution. Clear as mud. Moving on, number 7. We got a long ways to go. Negative 7, I'm just going to distribute this guy. We're solving an inequality. We're just going to do it the same way that we would if that was an equal sign. I'm not really going to do too much different. We might do one thing here in a second that I'll show you, but for the most part, we're just trying to get the n by itself. We're solving for n. So I'm going to start by distributing. Negative 7 times negative 7 is positive 49. Negative 7 times n is negative 7n. I'm going to bring down this part. It's a greater than symbol. Negative 28 is greater than this stuff. Now remember, we're trying to get, the ultimate goal here is to get that negative 7n by itself. So at this point, we're down to pretty much just a little two-step. You've got your negative 28 on the left, and we're going to subtract the 49 from both sides. So minus 49. That gets a little bit, I know I'm just kind of writing on top of everything. If I subtract 49 from this, negative 28 minus 49, you can take my word for it, it's negative 77. It's greater than, and I'm going to bring down, these go away, so I'm going to bring down that negative 7n. Now this is the one thing I told you is a little bit different whenever you're dealing with inequality symbols. The only difference between these and equal signs is that if you divide by a negative number, so the number that you're actually moving and getting rid of has to be negative. If it was a positive number, no big deal. But since that number is negative and we're dividing by it, that's where you have to flip your sign. And I think you guys are pretty good at that. So instead of greater than, it becomes a less than. Negative 77 divided by negative 7 is positive 11. And here's my n. Now be careful here because when we solved this, the n value was over here on the right-hand side, so I just kept it on the same side. That's what we should do. But the answers have the n value on the left-hand side. So we've got to very carefully kind of flip this whole thing around. But when we do so, we're also flipping around this inequality symbol. Because this means n is bigger than 11. Like it's the alligator is eating the n, so that means n needs to be bigger. So if I bring the n over here, the alligator needs to continue eating the n. We need to flip everything around. So just flipping it around can be a little bit tricky sometimes. But when I do so, the n will be greater than 11, like so. And so it'd be C. There we go. Number 8, if you're really having a hard time with this, you can just plug in our values. plug a 3 in where k is, et cetera, et cetera, et cetera. See which one gets you where you need to go. But what we are going to do is actually get the k by itself. This is just a two-step equation. We're going to start by getting rid of the thing furthest away from the k, which would be that -3. So I'm going to add 3 to both sides. And when I do that, I'm left with my k over 10 equals -3 plus 3, which is 0. Multiply by 10 on both sides. That goes away, and k equals 0 times anything is just 0. So that's where we'll stay. If you would have just plugged in the values, plugged a 0 in where k was, type in your calculator, you've gotten a -3 on that one as well. So that one's pretty easy. All right, number 9. Notice the star here. This is one where you could definitely use the rule of 2. So if you plug a little 2 in for the a values here, and then you're just going to see like, okay, what would it equal if I put a 2 in for those a values? Would it be the same thing? Or what about that one, or this one, or this one? And one of these answers will equal the same thing that this will equal. And that's how you know that it's the answer. So a great chance to do that. But hopefully we're also pretty good at double distribution. Some people call it the FOIL method. Or at least this part is the FOIL method, where you're going to be multiplying your first terms. So we'll go ahead and do 2a times 4a. So I'm going to multiply the big numbers. 2 times 4 is 8. And then I have 1a here and 1a there. So I've got 2 total a's. And so when we're multiplying those, we add their exponents. So that becomes an a squared. And then, so that's the first. And the outside, 2a times 6 is 12a. And then the insides, we're going to go back and do that -2 times 4. Be careful. Remember that it's a -2. A lot of people forget that. So we're distributing -2 times 4, which is -8. And then -2 times 6, which is -12. And then we're going to combine like terms if possible. Oftentimes the like terms are going to be together in the middle of your problem. Not always, but a lot of times that's where they'll be the same. See how I have an 8a squared, but I don't have any other a squared. So I leave it as 8a squared. I have a 12a and a -8a, so I can just combine them. Now be careful when you're combining. You're just adding, subtracting, that kind of a thing. So 12 minus 8 is +4, and the a just stays a. That doesn't cancel out or anything like that. And then you've got the -12 at the end. Cool. Where are we at? This one? That would be C. All right, this number 10 is asking you to find the slope of the line that goes through the following ordered pairs. So your slope formula, it's all tied together. It's all the same. I know recently we've been talking a lot about like rise over run, which is the change in y over the change in x. Like how much is the y value up and down changing? That tells you the rise. How much is the x value side to side changing? That tells you the run. But the very specific formula for this is y2 minus y1 over x2 minus x1. They're all the same thing. Change in y. To determine how fast it is changing, you just subtract the y values. And to determine how fast the x value is changing, you subtract the x values. So I am going to use this, since I have 2 points, to use the 1s represent the x and the y value from the first point, and the 2s represent the x and the y values from the second point. So I'm going to subtract my y values. There's my second y value. That's the y2. So -4 minus sign. And then the first y value is that 7. So minus sign and 7 divided by, do the same thing with the x values. 18 minus 7. Now you're just going to simplify it. So we take the top two. -4 minus 7 is -11. And then the bottom two, 18 minus 7 is +11. Negative divided by a positive is going to give me a -1. So there's my answer. That's how you do slope. This one, I don't know why this happens, but the C graph got like pushed onto the next page randomly. So that's kind of annoying, but it is what it is. Sketch the graph of the following functions. Now, one great option here is just type that into your calculator, and then it'll give you a really good idea of which one you're going to go with. Hopefully you knew that. Hopefully you thought about that. And if you didn't, please don't forget that you can use calculators. Those are really important. We do have a non-calculator section, but it typically it gives us questions that we couldn't really use the calculator for anyways. So things like this would typically be on a calculator section. So that's an option. Just type it in and graph it and see what it looks like on your calculator. But a couple of quick notes on this. This is quadratic, so it's x squared. That's why it makes that U-shaped parabola. And then it has an y-intercept of -4. Remember, this guy is always my y-intercept. Those are really nice to always look for because it's like automatic, like wherever it crosses the y-axis should be at -4. So that's just like a really quick thing to just look at and know what it is and see where it is on the graph. The other thing of note here is that the leading coefficient is an invisible -1. See how it has that negative in front of it? This means that my shape is going to be flipped down. It's been multiplied by a negative. So if that leading coefficient is negative, it flips down. If it's positive, it's up like a smiley face. So I can automatically kind of get rid of this guy and this guy. That leaves me with A that I'm looking at, and also the C, I guess, that's on the other side. So let's just focus on the A since that's the one we've got. Again, it's flipped down, so that's a quick and easy thing to look for. And the other easy thing to look for is that the y-intercept is at -4. And I know that I printed this like super small, trying to get a lot of questions on this without using too much paper. So it's a little bit tough to see, but you're young. Surely it's fine. So we're going down 1, 2, 3, 4, and that's where my y-intercept is. So that checks out, and that checks out. So A is looking good. Just to kind of prove it to you, if I flip this over, let me look at this guy back here. Oh, well, there's a -4 as well, and it's flipped down. So, so this also has the -4. Now it comes down to the vertex. So this vertex is at -1, -3. See right there, there's my vertex. And then you look at the vertex on the front side. I know this is super annoying, but I don't know. I just didn't want to redo the whole thing off of this one question. Anyways, this one is at +1, and it goes down 3. So the big difference here is whether or not the x value of my vertex is +1 or -1. And that's kind of going to lead me to which one is my answer. So I can do the old x equals opposite of B over 2A. That's how we get our vertex. Yay, or at least how we start the vertex, the x value, which is the one I care about here. My B value is -2. So opposite of that would be a +2 divided by 2 times the A value, which is a -1. So this would be 2 over -2, which is -1. So that means that the x value of my vertex needs to go to the left by 1. This one went to the right by 1 and then down by 3. So that would not be the one I want to go with. And wouldn't you know it, I'm going to end up with C, the one that randomly got pushed to the next page. And so the 3 different things that I kind of have going for me here. The y-intercept is -4. It's facing down because of the leading coefficient. And then the vertex goes to the left by 1. And then if I would have plugged that back in, it would have gone down by 3 as well. So there's my answer for that one. And we're on number 12, so let's do that one. It says, find the slope of the line. Now be careful, this is in standard form. So a lot of people will just say that it's like, oh, it must be like 7. Well, that's not even an option, so that's a bad idea. We have to solve this for y as a skill that we do a lot, a skill that we've already done on this review a few times actually. So I'm just going to get this y by itself using 2 simple little steps, the same steps that we use every time. We're going to move the x value piece to the other side. So I'm going to minus 7x from both sides. Remember, anytime you go to the opposite side, you have to do the opposite operation. So that goes away. Leaves me with a -2y equals, these are not like terms. So I'm going to put the -7x and then the 4. I'm going to divide everything here by -2. And now just simplify. So -7 divided by -2, negative and negative cancels, but 7 divided by 2 does not simplify. So I'm just going to leave it as positive 7 over 2. So I was at least able to get rid of those negatives. And don't forget to leave your x right there. And then over here I've got 4 divided by -2, which is -2. So there's the y equals mx plus b version of this. And then the slope that I'm actually trying to find That's the number in front of the x. So that changed to a positive 7 divided by 2. So let's go with that. That'd be C. Number 13 is another good one where you can use the rule of 2. So if you notice that you have variables in your problem as well as variables in your answers, it's a good indicator or a good guess to kind of just plug in a 2. It'd be quite a bit of things that you'd have to plug it into up here, but if you don't know how to do it, then that's, a way to get it right. So you might as well do it. And then you plug in a 2 down here in these answers to see which one gives you the same answer as you had above. The way you would actually do this when we're subtracting, one of the things we talked about with subtraction is it makes it a lot easier if you just go ahead and distribute this negative to everything that comes after it. Whenever we're distributing a negative, we're changing signs, but we're not necessarily changing like the value of the number. So this becomes a negative 8 into the fourth. This becomes a negative 4 into the third, and this becomes a positive 5 in. So notice I kept the 5 in and the 4 into the third power and the 8 into the fourth power. I just changed all their signs. Instead of positive, it became negative. Instead of positive, it became negative. Instead of negative, it became positive. So that's like the subtraction piece. And then the first part, you just leave it alone. So I'm going to bring that down. 3 into the third plus 2 in 4 minus 8 in. Now you're just combining like terms. You're just finding the things that are the same. So generally we want to start with the biggest exponent first. So I've got a 2n minus 8n. These are both to the fourth power, so I can combine those. 2 minus 8 would be a negative 6. You leave the n to the fourth power alone. And then I've got a 3 n to the third minus 4 n to the third, so that's minus n to the third, minus 1, right? 3 minus 4 is a negative 1. And then I have a negative 8 and a positive 5, so negative 3n. And that will match up with B part. Again, a great one to use rule of 2, where you just kind of plug in a 2. This, I'm telling you that skill can really help a lot of people. Because maybe you forgot about distributing the negative or something like that. But if not, that's how we would do it. Okay, number 14 requires reading, and you don't like that, so you're probably watching this video to get the answer instead of think about it. But you should have thought about it, because I think you could have gotten it. But that's why I'm here, is to help. So here we go. There are 50 students going on a field trip. The students are from 3 different classes. Mrs. Holder's class has 8 students. Mrs. Jones has 14 students. Which of the following equations could be used to solve for how many students are from Miss Rivera's class? Okay, so the key to remember here is that we've got a total of 50. So we've got 3 different classes that make up that 50. So if we take the number from each class and add them up, it should equal 50. So one class had 8. There's my 8. One class had 14. There's my 14. And one class had we don't know. So we just put a we don't know. That's where the R came from. But we do know that if you add up all 3 of those classes, it should equal 50. And since I'm using this first one as the example, then it must be right. So that's the one we would use. Obviously, it did not ask us to actually solve for R. We were just trying to set up the equation that would have worked. So pretty self-explanatory, I would think. It's just a matter of actually taking the time to read it and know what you're looking at. That's 14. 15. We're matching the graph with what's up here. The thing that makes this tricky, and I hope that you're watching this instead of missing it, because I'm sure that a lot of people might miss this. You have to be careful when your variable is on the right-hand side. It's just a matter of just remembering what that means. So we have an N on this side, and notice how the alligator's eating the N. So even though this is technically a less than symbol, less than symbols, which are like pointed to the left, because that's where the little numbers are. Since the N value is over here, all that matters is the order of things. The alligator's eating the N, so the N value is actually bigger than the negative 6. If you were to flip everything around, this sign would flip with it, and it would look more like that. So just be really careful that what this is saying is it's wanting us to identify everything that's bigger than negative 6. Another thing on this multiple choice options that is kind of nice is notice that this is just a greater than or just a less than symbol. There are no lines underneath it. So that indicates that I'm dealing with an open circle, and there's only one open circle. See how that thing is open at negative 6. And n is everything bigger, so we want an open circle pointing to everything bigger, which is to the right in this case. So just be careful. I know a lot of middle school teachers just kind of taught you to look at that sign and go whichever direction it tells you to go. And that is true, but only true if the variable is on the left-hand side like it typically is, like this. If the variable gets pushed over here, then it kind of throws you off a little bit. So just be aware of what's actually happening. Number 16 asks you to sketch the graph. Again, we've done this maybe 3 or 4 times already, where we're just getting the y value by itself. If we're going to graph the line, then we need it to look like y equals mx plus b. So in order to do that, I'm going to go minus x. Those go away. That leaves me with a negative 2y is greater than. These are not like terms, so don't combine them. I usually just put the x and then I put the constant, because that's how my equation's set up. And then I'm going to divide by that negative 2. And when I say divide, I mean divide everything by negative 2. We just got to divide everything on both sides by that. Now when you divide by a negative, be careful. That means we need to flip our sign. So this is, instead of being a greater than symbol, and I'm just going to kind of point an arrow, this is going to become y is not greater than, but y is less than. We have to flip that sign. And then you've got a negative 1x divided by negative 2. Negative and negative cancels. 1 divided by 2 is not 2. 1 divided by 2 is 1/2. So be careful there. And then negative 8 divided by negative 2 is a positive 4. So I've got a y-intercept of 4, a slope of positive 1/2, and I'm going to be shading below off of a dashed line. So hopefully you tracked all that. Y-intercept and slope, that's like graphing line basics. There isn't a line underneath this, so it's got to be dashed. And because its y is smaller, we're going to point to everything smaller. So when I look at my options down here, these are shaded above, so that's automatically out and automatically out because they're shaded the wrong side. These are both shaded below, they're both dashed. I'm looking for the one that is at 4, and it also goes up 1 over 2, so that looks like my guy right there at D. Ta-da! I know that this is annoying. These bottom ones got kind of cut and moved to the other side. Hopefully that doesn't throw you off too bad, because these aren't too terrible. Simplify the expression. This is one you could kind of plug things in, kind of a rule of 2 type of an idea here. But if you want to just simplify it, which I think it should be pretty simple, just simplify this. I'll do it underneath it. We got a little space. Negative 9 times 1 is negative 9. Negative 9 times negative 10 is positive 90a. And then bring down that minus 6. And then we are just going to combine like terms here. The negative 9 and the negative 6 makes a negative 15. They're both negative, so it's like ninja and ninja makes more ninjas. And then plus 90a. Now typically I would put the variable first and I'd put the constant last, but the reason I wrote it like this is because that's how they wrote it in the answer. Negative 15 plus 90a. There's my answer. So that's not too bad. And then number 18 beside it, it says write the following as a verbal expression, a times 6. This is just a matter of like, do you know what a times 6 means? And I'm sure you do. It's the product of a and 6. That's the word we use. Less than is obviously minus, divided by, decreased is another word for minus, but we want to multiply, and that's the product. So pretty easy on that one. Number 19, very, very easy if you know how to do it. But the thing you have to know to do is to put it in standard form. So it's wanting the leading coefficient. Probably the most common miss on this one would be to just to look and see that 3 and say that it's 3. And I'm halfway proud of you for that, because that's typically where the leading coefficient should be. But the exponents are in the wrong spots. Like, this is not in standard form. This is something we did way back in January, at the very, very, very beginning of polynomials, where we had to get it in the right order. So this is actually going to be my first term, x to the 7th power, because it's the biggest exponent. So it's going to be negative x to the 7th power that is first. Then I'm going to tack on this plus 2x to the 5th. And then the last one is actually this one to the 4th, because you're just going down in order for your exponents. X to the 7th, X to the 5th, X to the 4th. That's why this one is first. So the leading coefficient is actually this guy, which is an invisible -1. So just make sure that you get these in order first. Number 20, an increasing population of bacteria is modeled by this. What is the growth rate? So this one's a little bit tricky because we haven't, we've done a lot of work with exponentials, but when we talk about specific growth rates from a model, it's a little bit odd because it's already combined some things for us here. Just a quick reminder that any time your multiplier, your base, is bigger than 1, it's going to be growth. So 1.02 is almost 1, ever so slightly more. So that means it will increase. So that's good. Good to know. And it does mention that it's increasing here anyways. But this is really the way we would have typically written this when we did this together was we said it was like 1 plus 0.02 to the x or the t power. So we kind of split those up. We did 1 plus whatever the increase was. 1 plus, in this case, is the 0.02. So, and we called that right there, we referred to that as the rate. Now, this is written as a decimal. If we wanted to know what is that as a percentage, then we would just, that's the whole move the decimal 2 times. But we're kind of going backwards. See how we're kind of working our way backwards from how we would typically do this? So that would be the same as 2%. 2% is 0.02. It's the same thing as 2 cents. Like if you had 2 pennies, and I said, what would that look like? You would write it like this. Well, that's that, right? And so that's where, because it's increased by that much, that's good enough for me, that it has to be an increase of 2%. So not a very big increase at all, but increase nonetheless. Number 21. It says what are the roots? So you guys have actually done a pretty good job of knowing this. Roots, there's other words that mean the same thing. Roots is the one that we probably use the least amount, but this is the solutions or the zeros, and then the one that's really helpful here is that these are the x-intercepts. This is where are you when y value is 0. So that means we're on the x-axis, so it happens here at -2 and over here at +4. So you're just writing this out, -2, 0 and +4, 0, and that's all you have to do there. You're just saying where did it cross the x-axis. That's what a root is. Same thing as if it would have said 0 or solution, by the way. So yeah, that's cool. And then 22, this is a transformation. So we have a +4 that's on the inside of parentheses. Remember, inside means bad dog. Hopefully you can remember some good dog, bad dog stuff, because this is something you're going to see again in Algebra 2. So this is going to be the opposite, so the opposite of what you would think. You would typically think this is going to go to the right, but it's actually going to be shifting it to the left because it is a bad dog, and it needs to stay in its cage, or in its parentheses. So that's how that works. 23. It says, what's true about the slope and y-intercept of the 2 equations listed below? Notice they're both in standard form again, which is kind of annoying, but this is something that you have to do a lot of. It is what it is. We want to change these to y equals mx plus b. That'll help us see. Okay. That'll help us find a lot of things about this. So I'm actually going to give myself a little more space. I'm going to use this margin out here for this guy. 4x minus 6y equals 3. So we're just going to move my 4x over. It goes away. Negative 6y equals, don't combine them, just put them next to each other. 4x and a positive 3. And then divide everything by negative 6 and simplify where you can. Your calculator will help you with this. Negative and negative cancels. 4 divided by 6 does simplify, but it stays a fraction. So it's the same as 2 over 3. And then 3 divided by negative 6 is a negative, 1 over 2. I almost did the thing that I always get upset with. Negative 6 and 3. So 3 divided by negative 6 is not negative 2. The smaller numbers on top, so that would just be 3 goes into 3 once, 3 goes into 6 twice, so it would be negative 1/2. So just be careful on that. So there's this guy. And then we've got to do the same thing with this one. We've got a 2x minus 3y equals 6. I'm going to move my 2x over. It's the same two steps every time. Negative 2x plus 6 divided by negative 3, divided by negative 3, goes away. Y equals negative, and negative makes a positive 2 over 3. I know I'm going pretty fast, but we've done the same thing like 4 or 5 times now, so I'm sure that you're getting it. And there's the minus 2, the 6 and the negative 3 makes, that's how we get this. So I'm just going to compare my two answers here. Notice that their slopes are the same, they're both 2/3, but their y-intercepts are different. So we've got the same slope and we have a different y-intercept. But in order to know that, we had to first solve them for y. You could not have done that without doing this. When they're just in standard form, you could find the y-intercept by plugging in a 0 for x, but finding the slope would be really difficult here. We'd pretty much have to change things. So that's how we do 23. All right, 24. Here we go, 24. I almost marked this one out just because this graph is so small and it's kind of hard to see, but I left it because I noticed that the answers are just like kind of crazy. It says the population of the city, blah, 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 there's got this model. So it's exponential growth model, 42,900 times 1.1 times raised to the x power. X is the number of years since the city was founded, and Y is the population. So I think that this is really wanting you to do more of like a like plugging things in to actually solve for things. That's why it says to round your answers and things. But to me, I feel like this is a good thing just to use our brains and be logical about. It says based on the model, how many years after how many years was the population 69,000? So if I look over here, again, I know it's difficult to see, but you can at least make out the idea that this one is the 10,000, and then here's my 100,000, and so 69,000 is like in between these things. If this one is like the 10,000 mark, then this would be like halfway, and so we would want to go up a little bit more to like right here. So 69,000 would be somewhere around that little line, maybe close to that dot, not exactly. And then if these are the years since it was founded, so it would be pretty close to like a 6-ish, I would think. And then when I look at my options, I'm like, oh gosh, like there's only one that's anywhere close to that. So let's go with it. Like 32 would be way out here, 20, 41, like those would be way more. So just to get to 69,000, that felt obvious to me, so we'll just leave it there. Almost too obvious, kind of weird. This one is tricky, really tricky actually, because it did the one thing that I told you that we weren't going to focus on. So there's always a chance that this happens, that I say, hey, let's not focus on something, let's just kind of hope that it's not on there, and then it's on there, and then we are proverbially screwed. And that would be just a Mr. Ellis problem. But what's happening is you're looking at your graph and you're trying to figure out if there are linear functions. Now you guys were really good with knowing that means you're moving up by the same thing every time. And what I told you was we only care about the y value, not the x value. But I don't expect you to remember this, but I did kind of mention that the reason why is because the x value should be going up the same amount every time. But this is not. So we have 0, 1, 2, and then it skips to 5 and 6. So it's almost as if it like skipped the 3 and the 4, right? So it just kind of skipped up there. Same thing happens over here. 0, 1, 2, 3, 4, 5, 6. So it's like skipped the 3 and the 4. And that's just kind of obnoxious. That if you don't pick up on that piece, then you would immediately think that none of these could possibly be linear, because this is going +1, +1, and then like +3, right? So that would be not the same. That would be bad. And same thing over here, +1, +7, plus a lot. right? So it can't possibly be linear. But because we skipped that 3 and that 4, we actually do have one little linear piece here. There's different ways I could kind of explain this to you, but for a problem like this, just remember that it's almost as if it just left out the 3 and the 4 that should be going like kind of right there. And if it left out the 3 and the 4 on this side, we can kind of assume that it left out the 7 and the 8 and the 9 right on this side. So I would assume it goes 0, 1, 2, 3, 4, 5, 6. So now it's going up by 1 every time, right? And then over here, conversely, 5, 6, 7, 8, 9, 10, 11. So if we were to add those pieces back in there, now it is going up by 1 every time. 1, 2, 3, 4, 5, 6. So this would be linear. Now this one over here, it doesn't matter. This is growing real fast. It's pretty obvious, like 0, 1, 8, 125, 216. Even though there is a skip, like this is definitely not linear. Like these are not going up by 1 every time at all. Like even without knowing this, 0, 1, 2, 0, 1, 8, like that's already, not the same. That's a +1 and that's a +7. So I'm not even going to go into detail about the 3 and the 4 because it's already like not linear. So we can just get rid of that guy. That means table 1 is my only linear function. So that's a little bit tricky, but that's why. And that, if that happens, hopefully, just use your brain and work through some things and see if you can figure out a reason why it could be one or the other. I'm hoping that that's not the case. I would expect for us to have some table stuff, but I would expect for these to not have little holes and gaps. So we'll see. I could be wrong, but hopefully I'm right. 26, you could just plug and chug on this one. So this would be this little star. You could just take these, put this in for X, put this in for Y. And this one's tricky just because it says which one is not a solution. So if I plug these in, which one is not going to work? And honestly, that's kind of the best way to do this anyways. Like you could technically like solve this for Y and graph it on your calculator. Maybe use your table to see what the values are and some wild stuff like that. But you're probably best off just plugging these in regardless. And you're trying to, it's kind of a little bit trippy. 3 of these will work. 1 of them does not. So you're trying to find the one that does not equal 6. So I'm just going to start plugging and chugging. I have not done these problems, so I don't know which one to go with. And let's see, -3 times -8/3 equals 6. So 2 times the x value minus 3, that's where that came from, times the y value. Now these 3's will cancel. That's why a lot of these are fractions, but they're not terrible fractions. Notice they all have 3's in the bottom. So the 3's will go away. So you got 2 times -1 is -2. You can just type this in your calculator, I guess, but I just think it's easier this way. -8 is the same thing as +8, and that's going to equal 6. So -2 plus 8 does equal 6. So this would be a solution. Typically that means that would be my answer, but my answer is the one that's not. So the fact that this is a solution means I can cross it off. And then I'll just going to go ahead and do the next one. 2 times -2 minus 3 times 10, -10/3. Got that little extra negative in there. Equals 6. 2 times -2 is a -4. Negative and negative is positive. The 3's cancel, so positive 10. And that one also works. You have a -4, and this is the 3's canceled out, and the negatives canceled out, so you're just left with a +10. So pretty much all of that goes away. You're just left with a +10. -4 plus 10 is 6. So I can mark that one out. Alright, so we're down to just 2 options. It's got to be one of the 2. I'll put in the 3 and the 0. So 2 times 3 minus 3 times 0 equals 6. 2 times 3 is 6. And so that one would also work. So my assumption is that we are going to be working with this guy at the end. And if you wanted me to prove it, I guess I could but I don't want to. So, ta-da! There's my answer. We'll skip this guy. We're just going to hope that we don't have any of that. That's box and whisker craziness. And if they put boxes and whiskers on there, then dang it. I have failed. But I'm hoping they don't. They're not supposed to. This is old. Really old. George is helping a manager at a local produce market expand her business by distributing flyers around the neighborhood. He gets paid $20 a day as well as 5 cents for every flyer he distributes. George would like to earn at least, there's a big one. I'm just going to go ahead and underline it before, I don't even know, but I just know that's important. $65 each day. Which of the following represents a situation where X is the number of flyers distributed? So obviously he's getting paid to do a little bitty job here. He's getting paid $20 a day. So no matter what happens, he's getting $20. I don't know. Maybe he just stays at home and kicks it and still gets $20. That'd be wild. Surely he has to at least do something. But he's getting just the $20. That's why all of these have just 20s and there's nothing connected to them, because it doesn't depend on anything. Like, he's getting $20 no matter what. Now he's also getting like kind of a bonus here. This is called commission for those of you who end up in like business world one day. The more you sell, the more you make. So he's getting 5 cents for every flyer he distributes. So that would mean that he's going to add to his amount that he's making 5 cents, so 0.05 times the X. So he's not getting paid $5. That's silly. That would be a very, very high-paying job, and I would take it immediately. No, he's getting paid 5 cents. And so that leaves us with A and C, and the difference between them are these inequality symbols, and that's where the at least comes into play. When we say at least something, if I said you have to get at least a 60 in this class to pass, that means you could get exactly a 60, so you could be equal to that thing, but you could also get a bigger number. Like, obviously, like if you get something more than a 60, you still pass. So that means the amount that he gets paid needs to be greater than or equal to 65. Remember, this side over here represents how much money he's actually making. Like, we'll put in whatever, depending on how many flyers he sets out, that'll determine like exactly how much money he made. And he's hoping that the amount of money he makes is more than or equal to 65. That's what at least means. Cool. 29. Liz is saving money for a trip to the Caribbean starting in January. She puts $50 into a savings account each month after she deposits an additional $10. Okay, so she's going to put some money in a savings account. This is not super like real world accurate, because as we talked about before, savings account, they have their own kind of built-in interest rates where you'd be multiplying by something every time. But this is just saying that each month after she's going to deposit an additional $10. So she's going to open that thing with 50, and then she's going to put 10 more, and then 10 more, and then 10 more, and then 10 more. So we started in January. So in January is where she put it in the 50, I guess. That was in January. Into her savings account. And then each month after that, she deposits an additional $10. So in February, she puts in 10. I don't know. She just keeps doing that until it says December. So January and February and March and April and May and June and July and August and September and October and November, and then one more in December. Check this out. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 $10 deposits, and then the one $50 deposit. So hopefully you didn't have to put all these out, because you just know that there's 12 months in a year. And if you didn't know that, surprise, there's 12 months in a year. Now you know. So we're just trying to figure out how much money she has total. 11 times 10, that's 110, plus the 50 right here, and that's going to give me 160. So you just add all that up in your calculator if you wanted to. But from January to December, that's where she'll be. This is by nature a plug-in chug type of a thing. So this is like plug in a -3 for x. This is function notation. Don't let this confuse you. Function notation is just an introduction to the equation. Like it's a fancy way to say like y equals all of this stuff. We don't actually have to solve for this f or any of that stuff. It's just letting us know that the value we're putting in for x in this case is a -3. and then your answer is whatever you get on this other side. That's the part that matters. So -2 times the -3 plus the 3. You can type that into a calculator, and you get 9. There we go. Which situation cannot be represented by a linear function? So this is back to when, just very recently, when we were kind of talking about quadratic, exponential, and linear. Just remember what these things do. Linear means that we are adding or subtracting the same amount every time. It's a common difference. Whereas exponential means that we're multiplying or dividing by the same thing every time. So we want to find the adding and subtracting version of this. This says, which one cannot be? That makes more sense. Okay, I was worried. So that means we're trying to find the one that is not adding or subtracting. The first one says the cost to mail a postcard is 35 cents per postcard. So the idea here is that every time I sell a postcard, I have to pay another 35 cents. So you'd be adding 35 cents to your cost every time. Since we're adding 35 cents to my cost, or the other way to think of it is you're losing 35 cents every time, that would be linear. So we're trying to find the one that's not linear, so we can mark that one out. The distance traveled by running 5 miles an hour. If I run 5 miles every hour, that's kind of what that means, by the way. 5 miles. I don't know if you knew that. Maybe you didn't. When you're like miles per hour, like I drive 60 miles an hour. That means in 1 hour you would have gone 60 miles. Isn't that cool? Anyways, 5 miles an hour means that every hour you go 5 miles. You do another hour, you go another 5 miles. So you're just adding 5 miles every single hour. Plus 5, plus 5, plus 5, plus 5. So that's linear. The value of your home increases at a rate of 15% each year. Remember, anytime you see that percentage piece, that is an exponential thing. That means we're going to be multiplying by 1.15 every single time. So since we'd be multiplying, that one would be exponential. So that is not linear. So there's that. 32. This is another system of equations. Again, really, really, really good one to do, like just plug and chug. Like take the 3, -1, plug it in for 3 here, -1 here, see if it equals 5. If it does, then try the next one. Put the 3 for x and put the -1 for y. And if 3 minus 4 equals -1, and that would be kind of how it would be set up, then you'd be set for that one as well. So you're just trying to find which one of these would equal the correct thing on both of them. It has to work for both, by the way. But the way that we learned how to solve this way a long time ago, in case you're interested, is to solve it by substitution. Now, the last one of these I did by elimination. I don't know if you saw that one earlier or not. So I solved a different one by elimination. I did that because they were already set up with like the x and the y's kind of on top of each other. They were already lined up for me. So that's kind of easier that way. This one is already set up for me to solve by substitution. That y is by itself. This is the thing where we changed out like French fries for tater tots, if that rings a bell at all. This is kind of my equivalency. This is kind of like the key to my cracking my code. And then this is the one I'm actually going to use it in. So I'm going to be changing my y values to x minus 4s because they are the same. Right, they're equal. So in my first equation, I'm going to change the y to this. So I'm going to rewrite that first one as 2x plus, instead of y, I'm changing it to what it's equal to. This is where we said you could substitute out the French fries and input the tater tots because they're the same value. Or you can take out one side item and put in a different side item, kind of a thing. So this is x minus 4 and it equals 5. And the reason why we do all that is because now we're down to just an x instead of having an x and a y. So we can just solve for x here. 3x, just combine like terms. Add 4 to both sides. Divide by 3 on both sides. There's my x value. So that means my x value has to be 3. And then to find the y value, you take what you have and you just plug it back into. It doesn't matter what you plug it back into. I'm going to plug it back into this piece. It's just easier. It says x equals 3. So I'm going to put the 3 where the x is. 3 minus 4 I guess I should put that. Y equals 3 minus 4, and that means the y value is negative 1. There's the negative 1, so it'd be 8. Again, that's how you would solve this by substitution, or you could just plug values in. That works too. I don't care. 33. It says, what is the range value of this for f of 5? Okay. Sorry. Anyways, what I was saying is, number 33. What is the range value for f of x equals 2x squared minus 4x minus 10 for f of 5? So I put a star on this one as like a kind of like a, you're just like plugging in values type of a thing, but I didn't really need to because that's exactly what it's saying to do. It is saying take the 5 and plug it in for x and see what you get. So I'm just going to do this on this side, and then the answers are on the back, obviously. I'll move my other guy over. Yeah, see if he'll do one of these numbers. Ooh, that's good. I like that. So I'm going to put 5 where x is. 2 times 5 squared minus 4 times 5 minus 10. You can just type that into your calculator and hit enter. 5 squared is 25 times 2 is 50. Minus 20 minus 10. Hopefully I'm doing all of this correctly. It's really late and I need to go to bed, but I think hopefully my brain still works. So that'd be 20. Let's see if we get an answer like that on the other side, or else this is going to be awkward. And we did. Look at me. Yay. Me. Yay. So that would be 20. Good. The one beside it, it says that a change in C will affect, how is that going to affect the graph? Sorry, again, like it got cut off, I know. So that's this C. Notice it's inside parentheses. This is transformation stuff. So inside of parentheses means I'm going left and right. It's a bad dog, and it's the opposite. So plus actually means go to the left. So that means if I flip it back over, I'm going to be going to the left by whatever that was. And so it says, will it change the width of the graph? No, that would be like if you compress it and you make it like short and wide. So it's not going to change this. The vertical position is up and down. It's not going to change that. It's going to change the horizontal position. That's the side-to-side position. Specifically, it'll go to the left, but that's what we're going with. Whether it opens up or down, that's the negative that flips it or reflects it. Cool. Next. 35. For what value of x is negative 5x plus 8 equal to negative 6 a true statement? Again, I put a star on this as like you just plug in the values to see which one works, but that's actually how you would do this. Like there's not a whole lot else to it. Like you could just plug this in for x and see which one works. If you're actually going to solve it for x, we would subtract 8 from both sides. Bring down, this is a negative 5. It's weird that they added that little extra space, I guess. Negative 6 minus 8 is negative 14. And then divide by negative 5 on both sides. This is just a two-step. Hopefully you can do that. So negative and negative is going to be a positive. And then when you type 14 divided by 5 into your calculator, you'll get a decimal of 2.8. I usually say leave it as a fraction. So I would just leave it as 14 divided by 5, 14 over 5. That's just simple to me. But since they put their answers as decimals, then let's make sure that we put ours as well. There's that one. Okay, 36 is completing the square. If they put something about completing the square on there, then we're just going to miss it. And believe me, it's okay. Like you would have preferred to just miss a question than to have to go through the pain and the agony of doing completing the square. I'm assuming. I'll let your Algebra 2 teacher teach you how to do that. Now this is technically part of completing the square as well, but I left it in there because it's something that we can kind of do a bunch of different other ways as well. So we could do the rule of 2 here. So I put the star, so you could put a 2 in for x and see what it equals, and put a 2 in for those x's and see what they equal. Like you could do that kind of a thing. And so that would be like an option. And then the other thing that I've noticed is that it's set up in vertex form. Like this is vertex form, and this is standard form. They're both quadratics. They're both like U-shaped parabolas. Remember, U-shaped parabolas have a vertex. That's the kind of the important part. And so that's something else that I could use here. If I was trying to find the vertex of my original piece in standard form, I would do the opposite of b. So a -6 divided by 2 times the a. So opposite of b over 2a. Hopefully you remember that part. We did that earlier a little bit as well. So -6 divided by 2 times 2, which is 4. Make sure you don't just type all of that into your calculator, just one after the other. It'll be wrong. Do the bottom part first. 2 times 2 is 4. And then when we simplify that part, now it's going to be simplified to -3 over 2, which is the same thing as 1.5 or 1.5. So just remember what that means. That means it's going to be shifting my vertex to the left by -3 over 2. Right, so like on my coordinate plane, if the x value of the vertex is this, then that means it's going to have to be over here somewhere. And then if I look down here, these both have x values with a 3, so I can kind of immediately get rid of those. These have been shifted, this one to the right by 1.5, and this one to the left by 1.5. So that's where I want to go. I don't really need to do anything else. It's just -3 over 2 goes to the left. Even though this is a positive 3 over 2 or positive 1.5, we know that this is a bad dog. So that will actually shift it to the left. So that would change it to -1.5, which is the same thing. So I left that in there. There's a few different ways we could solve that. You could use rule of 2 here, or you can just know kind of how to do vertex of standard form and vertex form, which are two things we definitely spent a good amount of time working on, and hopefully you remember something. That'd be better than remembering nothing, I guess. All right, let's do some more, and then I'm gonna go to bed at some point. I guess I could wait. Is this all we've got left? I thought we had a whole nother. Yeah, there's a whole nother one. Okay. Well, forget it. We're just gonna do what we can. So here is 38. It says the cost of manufacture X pairs of flip-flops can be represented by the function this. If it costs $75 to manufacture 8 pairs of flip-flops, which of the following is true? So this is just kind of notation stuff. This is just making sure you understand how function notation works. So you have like f of x equals like an output or a y value. And so the input is the x value. In this case, the x value represents the number of pairs of flip-flops. In this specific scenario, it says that we're manufacturing 8 pairs of flip-flops, so that'll be the x. So go right there. And then the output value, the y value here, is the amount of cost. So it's like the cost of, in this case, it costs $75. So that would be kind of the output, or the y value. So the x value would be an 8, the y value would be a 75. So f of 8 equals 75. It's just that one. So hopefully that's pretty easy for us. Nothing to it. Just have to read, which is annoying, I guess. A beach company rents out chairs for $9 a day. They have a total of 100 chairs that can be rented. The function c of x equals 9x represents the amount of money the company can take in daily. What is the domain in this context? I actually copy and pasted this in as a daily practice question. It was a while ago, I guess. Maybe you remember that, maybe you don't. But this is asking for the domain. Domain means the possible x values. Like what would be reasonable, what would be realistic to use as my x values here. So we first need to know what did my x values represent. We're renting these chairs for $9 a day. We've got 100 chairs total, and it says to let c of x equal 9x represent the amount of money, that would be the c, that you can make daily. And I think it's pretty obvious here that the amount of money is dependent upon how many chairs. So the x represents the number of chairs that we rented. So two things about the number of chairs. Number one, you can't rent half a chair. There's plenty of scenarios where you can have a domain that is like includes decimals. all of our graphs, when we do domain, we do like all real numbers and things like that. That's because you could be anywhere on a graph and it's fine. But when you start thinking about the real world and how it works, that's not always true. You're not going to sell half a chair. I mean, I guess you technically could sell half a chair, but that's silly. Don't do that. So that means that when we're dealing with stuff, we're going to be dealing with, see how we have like the word whole numbers and rational numbers and integers and things like that. Like that means we're dealing with things that are complete integers or whole numbers. The other thing that we know is it can't be negative. That's why this says like non-negative. I can't sell a negative number of chairs. That's impossible. And then the last thing is in this scenario is this first part. It says they have a total of 100 chairs that can be rented. So you could sell 0 chairs. You could sell 1 chair. You could not sell a half a chair. That's impossible. You could sell 2 chairs. You could sell 3 chairs. These are all the pieces of the domain. These are all possible X values that would make sense. Like if you told me at the end of the day, hey, Mr. Ellis, we sold X number of chairs today, or we rented out X number of chairs today. Like you could have filled in the blank with 1 or 2 or 3, and I wouldn't have batted an eye. But this keeps going. Once we get up to like 99 chairs, 100 chairs, well, now we have a stopping point. Other than the idea that like someone could rent one and then you send them back and then we rented it, I don't know, send it and then you re-rent that one to someone else later in the day. We're just that's wild. This is here for a reason. Let's just leave it. You know what I mean? Like let's use the information that's given and just recognize that we're going to cap this at 100. We can't sell 101 chairs because we only have 100 and we only have 100. So when I'm reading all these, all whole numbers, that's wrong on a lot of accounts. All non-negative rational numbers. The rational could include decimals, but we can't use decimals. So rational numbers would not be good. All non-negative integers that are multiples of 9. Well, that would be true if we were talking about like our costs. That's our range. That's our output value. Like our cost would be the number of chairs times 9. So it'd be like $9, $18, $27. So that's not as crazy as it may seem, but it's also not right. We want to go with this. All non-negative, because you can't have a negative number. Integers, which means like a complete whole number. You can't have a fraction of a chair. Less than or equal to 100. Bingo. There we go. All right, number 41, what's the value? Okay, this is a good one. I'm glad they put this here. I hope that you've made it this far, and if not, well, this would be good. It says, if f of x equals all of that, what is the value of f of x when x equals 6? This is a plug and chug type of a thing. This is the same thing as if it said solve for f of 6. The x value, right, we changed the x value to a 6. So this is just plug in the 6 where the x's are. I should have put a little star on that one. Oh well. And then put it in your calculator and that's it. So 6 squared plus 2 times 6 plus 3. I just took this thing right here and I replaced all of the x's with 6's. And then type that in your calculator. That's 36 plus 12 plus 3. That's 36 plus 15. And so what do we get? 51. Bingo. Easy. 42. What describes the graph? Hallelujah. We don't have to solve it for y. It's already like, this says f of x equals. Remember, that's a fancy way just to say y equals mx plus b. So don't worry. Don't let that throw you off. It's just a fancy version of that. The slope here is going to be a negative 3, and the y is going to be a positive 4. So you're just trying to find that combination. Slope is negative 3, so it can't be these. These are positive 3's. Y-intercept is positive 4. There we go. Number 43 says, which is most likely the slope of the line graphed on the coordinate plane below? Kind of hard to tell exactly what else is happening here, but I think the line that it's talking about is this vertical line here. Vertical line crosses the x-axis at negative 3. So this would be like x equals negative 3.
Now be careful, because it's not asking what is the x-intercept. It's not even asking what's the equation. It's asking what's the slope. So these are actually terrible answers. That would be like up 3 over 1 or down 3 over 1. So there would be like a slant to it. These are better answers, and a lot of people get these confused. Vertical line, remember, slope is rise over run. The rise is happening significantly. So it technically you could put any number in for rise and it would be fine. Like it's going up by 1, up by 2, up by 3, up by 4. Like it's going up by whatever you want it to go up by. But the run, it's not going over at all. It never moves to the right, ever. It's straight up and down. So that would be a 0. Anything, like no matter what you put in up here, like no matter what that number is, if you divide it by 0, try that in your calculator if you don't believe me. It's an error. It's bad. You cannot divide by 0. That's why vertical lines have undefined slope. Hopefully you have that kind of just like memorized, but if not, like that's a way to remember it, is that a vertical line never moves side to side, so the bottom part of this is a 0. And that's bad. Which quadratic equation has solutions of 5 and 7? Put a big star on this one. You could just plug in a 5, plug in a 7, see which one works, that kind of a thing. Like obviously I think that's always like a really, really good way to do this. The alternative to just plug and chug would be a little bit tricky, but you can do this. Like I've given you all the tools. It's just a little bit tricky. So when we go from solutions, and we're going to have to turn this back into a polynomial. So we're kind of working backwards from the way we typically go. But regardless, when we go from factors to solutions, we always change the signs of them. Same thing as if we were to go from solutions to factors. And a solution of like x equals 5 would be the same thing as if I wrote x minus 5 as a factor. See how I changed the sign? And then this would be like an x minus 7. So you just have to remember that when you're going from a solution to a factor, or from a factor to a solution, we kind of change those little signs. And then from here, it's just like a double distribution piece, just to kind of get all the way back to where we started. X times x is x squared, x times this is negative 7x, negative 5 times x is negative 5x, and negative times a negative is a positive 35. Combine my middle pieces. I'm doing this quickly, but I think you should be able to follow my logic there, and then that gets me all the way back to here. So if you remembered to change your solutions back to factors, and then work that back to a polynomial or a trinomial, great. If not, that's great too. Just plug in a 5 where x is, like 5x squared minus 12 times 5 plus 35, you'll get 0. And then do the same thing with 7, you'll get 0, and so it will work. So that's pretty neat. Which one is equivalent to the inequalities? So this is just like getting the y by itself, very similar to how we would do like y equals mx plus b. I'm going to subtract the 4x to both sides. So I've got a negative 2y is less than or equal to, let's leave that alone, negative 4x plus 8. Now just be careful, because we're going to divide by that negative 2. And anytime you divide by a negative number, you have to flip the signs. So make sure, I think that's probably the big thing on that, is just making sure you remember to flip that sign around. So we'll have a positive 2x and a minus 4, but we flipped the sign, so we would be b. And then to wrap up this page at the bottom, come back. It says Lauren is working at a company that rents out boogie boards. Love those things. She's doing a good job and has earned $80 bonus in addition to her regular pay of $8 an hour. Her paycheck was $240. How many hours did she work? So hopefully you have a job where you get bonuses one day. I do not, but that's okay. I don't need them. I get summer break, and that's better. So an $80 bonus means you just get the $80. Like, doop, it's just 80. No more, no less. Doesn't depend on how well you did or anything like that. It's just $80. It's like, here's an $80 check. Have fun. Now she's also like, her normal paycheck is $8 an hour. So she's also making $8 per hour. So every hour she works, she makes another $8. This would be linear. And the total, if you add those two things together, was $240. So once you have it set up, it's just a two-step, minus 80 from both sides. 8H equals 240 minus 80. My brain is shutting down on me, but I still know that it's that. You can't have my brain sleep equals 20. So that means she would have worked 20 hours that week. That's a simple two-step. Which of the following sets of ordered pairs represents a function? That means the x values do not repeat. So we have a listing of points. All I'm really focused on are these x values. I've got a 1, a 0, a -2, and a 5. These do not repeat, so that is a function. If you look at B part, just for fun, you'll see that this has a -2 and a -2. Those are both x values, so that would be bad. If you look at C part, you've got a 0 here and a 0 here, and that would be bad. And then down here at the bottom, you've got a -2 and a -2, so that would be bad. So all of those have repeated x values, but this one does not. And that's the end of that page.